All right, so I built this had um, can't go out right now. So I built this to show you the relationship between the time domain, frequency domain, and the amplitude domain, time, frequency, and amplitude. And from this one 3D representation, I can show you how we end up at all of those different kinds of graphs that we've been looking at. So we can look at a time domain graph, a frequency domain graph, and a spectrogram from just this three-dimensional graph. Okay, so I mean, well, actually, I should say it's, yeah, you get to it from this graph. And what you do is you do that by like collapsing one of the dimensions. So let me get this in the light correctly here. So what you're seeing here is you've got two waves, right? This first wave, I can't figure out where I am in the camera. There we are. So this first wave right here, I'm just gonna look at it. So this first wave right here, the longer wave, the wave with a longer wavelength, which means it'll have a lower frequency, right? So you can see that it starts here at about the midpoint, the 0 point, and if it was just starting with a typical phase, it would go up, but this one happens to start going down. That's totally fine. So one cycle of this wave, where it goes from where it begins to where it repeats, is going to be all the way over to here. So that's one cycle. And so on this piece of wood, we've got 1.5 cycles, plus a little extra that you don't need to worry about. So there's 1.5 cycles here. So 1.5 cycles are represented on this graph. You can also see that the amplitude is 1, right? So it goes down to -1, it goes up to +1. Okay, so this wave is a little faster. It's got a shorter wavelength, and it's less intense, right? It's got a shorter amplitude. So it goes from -0.5 to +0.5. So it's half the amplitude of the first wave of the lower tone. And then this wave begins coming down from its first peak. So here's 1 cycle, 2 cycles, 3 cycles. So this is 1.5 cycles represented. This is 3 cycles represented. So these are harmonics. Well, they're harmonics. And this one here, the shorter wavelength, the higher tone, is the second harmonic of this fundamental frequency. So what you're seeing here, you can probably tell, is let me turn it. If we go like this is just the time domain. From time domain, you can figure out the frequency of each wave and the amplitude of each wave. Now, this is how you get to a frequency domain. You just simply turn it. I'm going to have to angle it a little bit to get so I can get my light in there. Oh no, this will work. Okay, so if you turn it like this, see those frequencies become lines because we're collapsing across time. And you can also see that the first wave goes from down here, where's my finger? Right here, or actually right here. This is the furthest down it goes, is right here. And all the way up to here. So the line that it creates is much longer than this wave, which has a much shorter amplitude. Let me get it so you can see that. Okay, there. So the first wave has a shorter amplitude. The second wave has a much larger amplitude, which we know is true when you spin it around and look this way. So here we've got time domain. You spin this group of waves around, and then you get frequency domain, and amplitude is still there. Okay, so now let's show how you get to a spectrogram. Well, you're going to turn it this way. So now we're collapsing across amplitude. And what I'm showing you is, so time should still be here. Let's get rid of amplitude. There we go. And time, I'm going to tilt just a little bit so you can see it. So time is still here on the bottom. And we've got frequency. These lines, you can't see their amplitude anymore, but you can see that they are lines of frequency. So these frequencies are represented across time. Now, if this was a true spectrogram, these would be darker, and that would correspond to the amplitude of the signal. It's how intense the signal is. I can't do that with wire, but this is how you get to a spectrogram. So this is a spectrogram. This is your time frequency plot, time amplitude plot, and this is your frequency amplitude plot. And it all comes from one, oh, I've turned my wave. Darn it. There we go. So it all comes from just this one three-dimensional graph. You can get all of those other graphs. That's how they're all related. It's really all one thing. It's all one sound signal. But if you collapse across one of those, you can make a two-dimensional graph, which then can be represented on computers and papers and posters and all sorts of things, textbooks. And you don't have to build a wood and wire graph for every sound that you're looking at. Okay, that's it.